All right, I always want to do a little overview video on the architecture of making your own menu or window system. The architecture of how you would design one of these things is remarkably similar to how you design an entity system. What do I mean by that? Well, each entity is a singleton in a managed environment. You will do the same thing with an entity system. So you'll have a managed menu system where I have many menus. Each menu is unique, has a position on the screen, and does things. Menus themselves, or windows if you want to call them, have different elements. Elements can include, but are not limited to, labels. So that's things like text. Sprites or actors, your images. We can have buttons, which will have include both the above. Text entries, which is a lot of work. Text entry. And then that can sometimes be filtered for numbers sometimes. You can have sliders. You can even have containers of elements. So we could have an element list. Element list. And then we can have that our horizontal or vertical. Wrapped or not. Capped with offset. These things can get complicated. Menus themselves are going to have, let's make a new slide for this one. Let's duplicate this slide. Let's call this labels, or no, menu elements, or let's call it window elements. Widgets is how they're oftentimes referred to in a lot of UI things, but widgets was a term originally coined in economics to just mean a unit of production, and I don't like reusing that term. I prefer the term window elements or windels. Like pixels is picture element. Voxels is volumetric element. Texture coordinates or texture elements or texels. That's kind of like a convention to name stuff already. So windels would be what this would be called. So that's what this would be. Radio buttons, all the different things that you would get from like an HTML layout, making like an input form. Anything that you'd want to support. And the window systems themselves, they're going to have some properties like that. So each menu is going to have some properties that we're going to deal with, like say position, where to draw it on the screen. A list of elements. See the next slide. Maybe child windows or parent windows, depending on how you want to do. The system itself is going to organize a list of windows. However, we're going to iterate through it one way. We draw back to front. We update front to back. So that list of windows we're going to have to go through in one direction, to do one thing, and in the opposite direction to do the other thing. Generally, the last thing on the Windows stack, it really is, list of windows is more of a stack, so that we can draw back to front. So the bottom window is going to be overwritten by the top window, but the top window should be the first thing to get input. And what I generally will put a window update function that when it runs its update will return if or true or false, depending on whether or not you should continue down the stack of windows to update. The idea is that if a window has captured input, I don't want a window behind it to also capture that same input. So just because I press the button in this one window doesn't mean the window behind it should capture that input. Or if I clicked some in a window and there happened to be a button behind it, I don't want my user to click that event. Generally, what I would do is window updates would come in the form of a generic function pointer for an update. And the process of defining what these windows does is, if you've worked with Windows systems before, you may have done it with a callback system, or here's all the events that happened, now handle it system. So it's up to you how you want to define it, or how complicated and robust you're going to end up creating it. The event-based system is you're going to define a window function update. So it'll be an int, and then it'll be, my main menu update, and it's going to get a list of updated elements. And then generally, I know my pointer to myself, because it's C, not C++. And in here, we're going to iterate through the updated elements and see if I handle any updated things. Also, do any custom logic here, and then return true if I handled input, false if another window can do stuff. That's what that would basically do. The Windows system is going to be to do updates. It's going to be a for each window, and then for each element, call the element update function. For a label, like just text, there's nothing to do. For an image, maybe we animate a sprite, but we actually don't do anything. For the button, we'll check to see, hey, is the mouse over me? Have I been clicked? And if so, then I would add myself to the list of updates that would happen for that window, and then we'd pass that compiled list to each window to handle. Going back to elements, all of them element data, we're going to have maybe an ID number. It needs to be unique. A name should be unique. And position on the screen, or position relative to the window, maybe even as a percentage. So if I scale the window, things will align correctly. Color, mod, alpha, anything else like that. And then specific things like, so labels would, what's going on here? You'll have your subtype, which would probably make it a union, or custom data pointer. Just like how we had custom data pointers with entities, we could have a custom data pointer with window elements. And so when I have a label, when an element is a label, I can have a label data, which would include the text, the font style, text color, or alignment. Maybe you want to handle left alignment, center alignment, right alignment, things like that. Then we can have image label data that it's going to have, like the sprite, our frame, any kind of scaling or any kind of rotation, anything else that we want to support for that. And then say buttons is going to have state. States could include none, highlight with the mouse over it, or selected, and then pressed, released, and then the button data itself is going to have a label and a sprite, and so on and so forth. And then you figure out what kind of things you want your interface to be able to have. And the cool thing about all this is, once again, you have something like, if you want to drive stuff off of config, I can just open up an example from one of my other projects where I have used that. Let me go to Glyph. That was my 2D platformer. And I have a menus folder. I'll just open up the main menu, see what that looks like. So I've got window where it's positioned on the screen. Maybe you have an alignment, the elements in the window, button, and there's you'll basically only need to list things that are not default. So this is an example where a button doesn't even have any graphics associated with it or any position on the screen. It just has a hotkey. So I added a hotkey system based on the inputs, which is based on GFC input. So if you want to work with that, you have named hotkeys for things. Here's a list that it's a vertical, the vertical bounds for it. Each item has a size of this, and then each element has, so there's a label, and there's a list, and in this list we have this button and that button. And then in the code, I would check to see for things like I load my window from the JSON, so it'll parse the JSON, build all the elements, create the window. I then need to manually set what its update, its cleanup function, its draw function would be. Actually, I don't think the draw function does anything special for this one. It draws a big background image. That's all it does. And then the update function takes a pointer to the window, takes a list of updates, gets my custom window data, because sometimes my different windows need some additional data, so the window themselves might have a custom pointer, which in this case has the background image, a file name, a pointer to itself, and a selected option. And so iterating through the list of elements, comparing the name of the element to see what to do, and then quit. So that's the concept behind a window system. This one's involved, as many things do in my own code base. I went off the walls and didn't need to keep it as easily understood to new programmers. But if you do look in the SDL, not the SDL, the game framework 2D other libraries, you may find some sample code that works with it. But I do warn you about looking at some of my side projects that are all in different branches of GF2D. They get complicated. I gave you all a minimalistic base on purpose. I wanted to start simple so it's understandable, with a couple use cases, some design patterns to follow, and that you evolve from there. But if you want to venture into more complicated things, you can see I've got some code base, some code examples of particle systems and more robust entity systems and physics systems, and all the bells and whistles to make a 2D game are there. I have parallax backgrounds, I have lighting and shadow mask layers, and all kinds of advanced topics. Not all necessarily easy to understand, though, so I warn you that it's not as well written as far as readability is concerned. It's written for more functionality efficiency. Sometimes readability sacrifices for that stuff. Anyway, this is just a brief overview of what you'd want to do for a Windows system. A complete, robust Windows system is not required for the midterm project. But as the final is going to require you to make a content editor, if you go ahead and make a more robust Windows system, it'll make the content editor that much easier to work with. All right. Hopefully this is helpful. Thanks for watching.